intelligence is a field of computer science that attempts to create machines that act rationally in response to their environment. It's been around for quite some time. In fact, artificial intelligence dates all the way back to the 1950s. Now, in the past, we had some machines that were capable of making rational decisions. However, they had to be explicitly programmed to do so, and they could only operate successfully within a very constrained set of environments, or within very constrained environments. There was a lot of hype about what artificial intelligence would be able to do, and many experts, even back in the 50s, were predicting that very soon machines would be doing all human labor or replacing all humans in most labor. But this never happened. And by the end of the 90s, machines still couldn't even solve basic problems that even a toddler could solve. The inflated hype about the potential of artificial intelligence and subsequent disillusionment when none of this stuff actually happened led to what we now refer to as the AI winter, a period of time between the late 70s into the early 2000s where funding for artificial intelligence and research had almost entirely dried up. However, by the mid-2000s, the AI winter has ended and things are starting to warm up again. So we're going to take a look at a few examples of modern AI, the types of artificial intelligence we're seeing actually doing real work in the world. The first example here is something called the Tipsy Robot, which is a bar in Las Vegas, Nevada, which is where I'm from. The Tipsy Robot bar essentially is set up so you walk up to your table to place your order for a drink. There's no human waiters or waitresses. Essentially, you type your order into a little tablet computer. You can make your own drink, too, if you don't see a pre-mixed drink on the menu. Then the machine goes off and makes your drink and then places it in this little cup, which then gets passed on a conveyor belt right to your table. So the entire process of making drinks is completely automated. But now, keep in mind, this is still explicitly programmed artificial intelligence. So a human being is actually telling the machine, you need to move your arm 6 degrees to the right, 2 inches to the left, and then grab like an ounce of this liquid, now grab an ounce of this liquid in order to make your vodka martini extra dry. So this is still kind of traditional artificial intelligence at work. But as you can see, this type of artificial intelligence does a job that a human being once did, or that 2 human beings once did. But now, I was in Hamburg, Germany here recently, and I saw this little guy drive by. I was just sitting at a table having dinner, and this thing just passed right by me. I'm like, what in the world is that? And I just had to know. So I found out that this thing was a fully autonomous delivery robot by a company called Hermes and Starship, and it's been successfully delivering packages in Hamburg, Germany since 2017, and they've since expanded it to the UK and a few other locations. It actually works quite well. You can put your package in the robot, give it the destination, or your pizza, whatever you want to put in there. The person at the receiving end gets a notification on their smartphone when the robot arrives, and they simply type in a little code or push a button, and that unlocks the robot and gives you your package. Simple solution, and this is a combination of both data-driven artificial intelligence and a bit of explicit programming. But to see where we're at in terms of pure artificial intelligence, machines learning without human beings teaching them whatsoever, we're going to take a look at an example. This is referred to as deep reinforcement learning. Pretty cutting-edge stuff in the artificial intelligence space right now. This game is Atari's Breakout. Some of you may recognize it. An old video game that involves the paddle, and you bounce the ball in order to hit the blocks on the top. So now, this machine, or this piece of software, has been given no instructions by the human beings. It sees the array of pixels on the screen, just like a human being does, and it can send 2 commands. It can move left, or it can move right. Or stay still. That's pretty much it. And then it's also receiving the score. So it knows what the score is of the game. And all it's told is maximize the score. The machine, when it starts out, after just 100 training examples, you can see it really doesn't understand the game very well. It's going to miss the ball all the time. It's pretty much just moving at random. Every now and then, though, the ball will reflect off of the paddle, and it will score a point. So it begins to detect this pattern that when I have the paddle underneath the ball, I score a point. So let's keep moving the paddle under the ball. And it eventually learns how to play, or learns the physics of the game and essentially how to play the game. By 400 training iterations, it's essentially playing as well as most like expert or average to expert players. It understands the physics of the game, it understands how to score points, and it essentially understands how to win. But something really interesting happens right around 600 training examples. The AI discovers this technique called tunneling, something the experts do when they're playing the game. You bounce the ball along the walls to build a tunnel up to the top, and then essentially just allow the ball in the upper wall to do all the work for you. It maximizes your score, minimizes the time it takes to maximize that score, and reduces the likelihood of losing a life with the ball actually hitting the ground if you miss it. So In a very short period of time, I mean, this is only 600 training iterations, this machine has essentially figured out how to play this game without any human instructions, essentially other than maximize your score. So now let's take a look at a more practical application of this technology. So this is Google's voice assistant. Essentially, you take your phone and you ask it things, or you give it commands like, make me a haircut appointment Tuesday anytime between 10 and 12. And it says, no problem, I'll make you an appointment and update you soon. Now, on the back end, the machine goes off and it makes a phone call to a live human being in order to place this appointment. So now, keep in mind that the human being on the other end of this phone call has no idea that they're talking to a machine. So I personally think that's pretty impressive. When you think about all the complexities of solving a problem like that, all of the data it has to have access to, it has to be able to understand the human voice, it has to be able to understand grammar and syntax and context, and be able to handle novel scenarios, things that questions it's never heard before. Like, that's a pretty impressive thing to be doing. So the next question we need to address is, why is AI important? Or why has it become so important again all of a sudden? You know, what caused the artificial intelligence winter, the AI winter to end? And why should we assume that today or this time is going to be any different than last time? Why shouldn't we just assume that we're going to hit another AI winter here in the very near future? Well, to understand why, we need to look at 4 trends that are really driving the artificial intelligence movement forward. We're going to look at data science, the Internet of Things, big data, and machine learning. These 4 trends are essentially both making artificial intelligence possible, but they're also increasing the value that artificial intelligence can provide. Finally, we'll close this loop by showing how all of these trends are essentially converging to create fully autonomous intelligent systems. This is the future of artificial intelligence, and the future is software as we know it. And I apologize that we have to look at a lot of buzzwords, but these buzzwords are actually critical to understanding why this is actually happening and why this is becoming so important these days. All right, first, data science. So data science is an interdisciplinary field composed of computer science, math and statistics, and domain expertise that seeks to derive insight from data. Data science is essentially the intersection of these 3 respective fields. Another way you can think about it is that data science is essentially the intersection of data engineering and the scientific method. We're using large-scale data systems to drive the scientific method. The goal of data science is to transform data into knowledge that can be used to make rational decisions so that we can take action to achieve goals of some kind. We refer to this process as transforming data into actionable insight. So there's a rapidly growing demand for people with the data science skills and the ability to transform data into actionable insight. In addition, many of the top-paying IT skills right now all involve data science school tools and skill sets. So the business world has begun to embrace this idea of using data science as a modern way of making informed business decisions. This means that it's now widely acceptable to use data analysis in the scientific method to solve common business problems. This is leading to the emergence of what we're referring to as data-driven enterprises, organizations that value information as a strategic asset and base all non-trivial business decisions upon data. And initial findings from MIT research show that companies that are leveraging this style of data-driven decision-making are showing 4% higher productivity and 6% higher profits than traditional businesses. And now, while these numbers might seem small to some of you, let me assure you that this is a difference in highly competitive markets between companies that are essentially dominating a market and companies that essentially will cease to exist in a market in a few years. In fact, we've already seen several industries that have been completely disrupted by the emergence of data science in the industry. First, the financial industry. So just a few decades ago, the trading floors of Wall Street used to be filled with people yelling and screaming day in and day out, well, at least until the stock trading floors closed, to buy or sell stocks, bonds, and other securities. However, the trading floors are almost completely empty these days. Stock trading was taken over by quantitative analysts, also known as quants, sitting in back offices and using data science in order to predict investment opportunities. And now these quants have essentially replaced themselves with high-frequency trading algorithms, essentially artificial intelligence algorithms that are predicting what to buy and what to sell in the stock market. And this now accounts for the majority of all stock trades in the modern stock market. So as we can see, the financial industry looks entirely different than it did just a couple decades ago by the adoption of data science and the use of artificial intelligence in that industry. Next, we have baseball. Prior to 2002, picking a lineup of players in a Major League Baseball draft relied largely upon traditional measures of player performance, metrics like stolen bases, runs batted in, and batting averages. And there was a lot of human bias involved in the scouting profession. However, in 2002, the Oakland Athletics baseball team used data science to select players that were significantly undervalued by the marketplace. Despite their significantly smaller budgets for player salaries, the Oakland A's created a team that was competitive against much better funded teams. This data-driven strategy led the Oakland A's to set a record 20 consecutive wins and brought them to the playoffs in 2002 and 2003. As a result, the game of baseball and how players are valued has been changed forever by data science. Finally, the insurance industry. So the insurance industry has been using data and statistics for years to calculate the aggregate risk of the individuals that they insure. However, small insurance startups are using very fine-grained data and much more powerful analytics tools to completely disrupt the insurance marketplace. With the emergence of pay-as-you-go microinsurance and the near-perfect safety records of fully autonomous vehicles, traditional automotive insurance may completely disappear in the next few years. As a result, the insurance giants are currently scrambling to leverage the power of data science before it's too late. In fact, I have several clients in the insurance industry that I can vouch for that essentially feel like they are way far behind because everyone else is much further ahead with this data science technology and the use of these technologies to improve their business. So as we can see, the insurance industry is currently in the middle of being changed forever by data science. So data science is becoming a major force of disruption in the business world. It's beginning to impact almost every sector of our economy. Anywhere you can use data to make better decisions than your competitors, to build smarter products than your competitors, or to automate knowledge work, you see data science rapidly becoming the deciding factor between the winners and the losers in the information economy. As a result, data science is essentially the heart of artificial intelligence. It's this life force that's driving the AI movement forward in the business world. However, a beating heart is useless without a body to inhabit, which leads us to our next topic, the Internet of Things. So the Internet of Things is the emerging trend of connecting all devices and sensors via the Internet. It's essentially the digitization of our world. We've seen an explosion in the growth of IoT devices over the past decade. In fact, it's predicted that the total number of IoT-enabled devices will reach 50 billion devices by 2020. That's over 6 Internet-connected devices for every human being on the planet. We're connecting our bodies to the Internet. We're connecting our automobiles to the Internet. And we're now connecting our homes to the Internet. But this is just the beginning. Given the economics that are driving this trend, we will eventually connect all human artifacts of any real interest or value to us via the Internet, even the weird stuff. For example, we now have Internet-connected toilets. Yes, they can track how frequently you flush, whether they're clogged or not, and they can even play your favorite music when you sit down. And in the near future, they're going to be equipped with sensors that will detect key health indicators like pregnancy, bacterial infections, and even prostate cancer. We also have IoT toasters now. Yep, you can toast on the Internet. Smart toasters allow you to perfectly toast your bread based on your custom user presets, print images, logos, and text on your toast, and receive notifications via your smartphone when your toast is ready. And you can even send toast messages to others via the ToasterNet and play a game of tic-tac-toe slice by slice on the Internet as well. Now, I don't know how much real value something like this provides, but this just is going to show you if this Internet enabling gets cheaper and cheaper and cheaper, they're just going to connect everything to the Internet if there is any value whatsoever to it. And we even have IoT-enabled cows. Yes, an Internet of cows now exists. The problem has been solved. These cows are equipped with sensors that track movement, behavior, fertility, and even lactation. The devices and sensors that make up the Internet of Things are generating a tremendous amount of data. Data that can be used to enable machines to solve problems with modern, data-driven artificial intelligence. We're currently in the midst of building a peripheral nervous system for our world, or for our entire planet, similar to the nervous system of our own bodies. Essentially, the Internet of Things is the body that artificial intelligence is going to inhabit. It allows artificial intelligence to observe and interact with the world around it. However, it still needs a brain, which leads us to our next topic, big data. As a result of the Internet of Things and the digitization of our world, the amount of data that our world is generating is growing at a tremendous rate. In fact, the amount of digital information that our world creates and stores every year is roughly doubling every 2 years. This means that in the past 2 years, we have created more data than the entire history of the human race. So big data is a term that's used to describe data sets of a volume, velocity, or variety that's beyond the limitations of conventional computing architecture. As a result of big data, we've had to invent a new set of technologies that take us beyond the limitations of conventional data processing. By volume, we mean the size of the data. Big data means data sets that are too large to be processed on a traditional or conventional computer. So we've invented distributed computing technologies like Spark and Hadoop, which spread out the storage and processing across multiple computers. By velocity, we mean the speed of extracting insight from data. Data processing overnight in daily or nightly batches is just too slow to remain competitive these days. So we've invented lightning-fast streaming analytics tools that allow us to make decisions in real time. For example, detecting credit card fraud before the credit card transaction has completed. By variety, we mean the various types of data we need to process. We're not just dealing with tabular data in a relational database anymore. We're dealing with text, images, audio, and video coming from a variety of different data sources. So we've invented a new set of tools that allow us to handle semi-structured and unstructured data. We can now derive information from types of data that would previously have required a human being in order to analyze. So big data technologies allow us to find patterns in massive data sets, patterns that we couldn't have seen before without these big data tools and technology. And this has led to some pretty interesting and some kind of creepy discoveries. For example, we now know that beer and diapers are frequently sold together as a result of one of the first big data retail analytics projects. And now this is useful information because you know that you should probably place the beer next to the diapers in order to increase the likelihood of impulse purchases. In addition, we also know other interesting fun facts about human behavior, like purchasing certain products like mineral supplements, extra large bags of cotton, and large amounts of unscented lotion all together are a strong statistical indicator that you're likely to be pregnant. And a major US retailer can actually use your product purchases to predict the due date, your due date with a very high accuracy. And we can even make accurate predictions about hurricanes. Well, not about the hurricanes themselves, but what we can accurately predict is that sales of strawberry Pop-Tarts, those delicious breakfast pastries, will increase 7-fold in the days leading up to a hurricane. In fact, another major US retailer actually ships truckloads of these delicious survival breakfast foods in the paths of hurricanes right before they make landfall. So all of these super interesting discoveries were the result of big data tools and technologies. However, that's just the beginning of the super cool and interesting stuff that we're eventually going to learn about human behavior and patterns. And there's probably a lot of other really creepy stuff we're probably going to learn in the very near future as well. In fact, if you're interested, I'd be happy to tell you about some of the other super creepy stuff I don't feel comfortable sharing in public out in the hallway during the Q&A session afterwards. So ultimately, big data technologies allow us to store and process massive amounts of data, data storage and processing capabilities that artificial intelligence needs in order to function. Essentially, big data technologies provide us with a brain for artificial intelligence. However, it still needs a mind in order to think, which leads us to our next topic, machine learning. Machine learning is a subfield of artificial intelligence based on statistics. It involves machines learning how to solve problems without being explicitly programmed to do so. It does this by detecting statistical patterns in data. Essentially, with machine learning, we use existing data in order to learn a function that we can then use to make a prediction given new data. So if you remember back from high school algebra, a function is essentially just a mapping between an input and an output. So with machine learning, we're simply just mapping data as an input to some kind of prediction as an output. It's actually relatively simple. For example, if we're trying to make a function that essentially determines whether a photo contains an image of a cat or not, the first thing we need to do is create a data set of images containing cats and not cats. And then we label this data set indicating whether that thing is a cat or not. A human being will go through and do this labeling. Then we apply a machine learning algorithm to that data set of images with and without cats, and that algorithm essentially learns what catness is. It learns what is it about an image that strongly correlates with it being a cat versus being not a cat. And that's a pretty complex set of relationships that you have to analyze. So if we've done everything correctly, we should be able to provide the machine learning function, the model that the algorithm has created, provide it with a new image that it's never seen, this little guy over there, and it should tell us whether that new image is a cat or not, and the statistical likelihood that what it's seeing is actually a cat or not. And now, while this is a vastly oversimplified explanation of machine learning, it essentially captures the essence of what it is that we're attempting to do with this technology. There's a lot of things that we can do with machine learning these days. Some examples of tasks that machine learning algorithms can perform are classification, where we attempt to make a decision or a prediction that falls into one of two or more categories. For example, predicting whether we should approve or reject a loan based upon a customer's financial history and demographic data. Regression, where we attempt to predict a numeric outcome based on a set of input variables. For example, trying to predict how much a house will sell for based upon the sale prices of similar houses. Clustering, where we group objects together based upon similarities in their data. For example, grouping customers together into marketing segments based on their demographic data and other attributes about them. And anomaly detection, where we find observations in the data that are different from the normal data. For example, detecting credit card fraud from normal transactions. And that's just the beginning. In addition to doing classification, regression, clustering, and anomaly detection on tabular data like we saw, we can also use it now on a variety of other inputs, including text, images, audio, and video, and produce a variety of outputs, including text, images, audio, and video. And this allows us to do some pretty interesting things. For example, we can now do real-time object classification, image segmentation, and motion detection. All of this stuff is now happening in real time. But we can also generate synthetic data as well. In fact, the following imaginary celebrities, that's right, imaginary celebrities, were created using a deep learning celebrity generator trained on 200,000 celebrity images. So not a single one of these, even though they look like people you've seen before, are a real person. In fact, we can actually watch as the algorithm gets progressively better at creating celebrities. So you can see it's progressively getting better here with each day that has been trained on the data set, and its resolution is improving as well too as it's being further trained. So by the time you get to about 10 days of training, this algorithm is able to produce faces that look like real celebrities because it's based on real celebrities, but is not an actual human being. Oh, I guess about 20 days in. And now check this out. So the following 4 videos were created by a lip-syncing deep learning algorithm. Keep in mind, all 4 of these videos are completely synthetic as well. They are fake.
To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs.
So you can see how concerning this technology is going to be if society is not prepared for this kind of thing. And I assure you, the majority of society does not know that this technology is possible. They don't know that it's capable of producing fake images or fake news, if you will, of this caliber yet. So this is why it's so important that we help communicate to the general public that these technologies exist and to watch out for these kind of things. Now, on a lighter note, deep learning algorithms are currently being used to train artificial bodies how to walk. And once you can get a virtual body to walk in a computer simulation, you're a very big step closer to getting a real body to walk in the real world. And I should probably note that this is pretty early on in the training set. This thing has gotten so good at walking that it's better than me. You can like throw a boulder at the thing, it'll just wobble a little bit, and then it will recover and just keep walking going about its business. But it's way more fun and interesting to watch it early on in the training set because it's just clumsy and does stupid things. Yeah. Now, that's probably a pretty successful strategy for walking, but none of us have ever tried it before. Maybe it would work better. And that leads to pretty cool stuff like this. That's loud. Many of you are probably surprised that robots can jog now, but that's a thing. And check this out. I don't know about you, but I certainly can't do that. I couldn't have even done that in my 20s. And speaking of other things that machines can now do that better than human beings, modern machine learning is now better than humans at a variety of tasks that you may not be aware of. For example, most board games, 8-bit video games, and card games, even poker. Communications tasks like speech recognition, language translation, and even lip reading. And a variety of medical tasks like diagnosing certain diseases, recommending prescriptions, and tailoring treatment plans based on each patient's individual genetic code. And machines are getting better at new tasks every day. However, while machine learning might be really good at a bunch of tasks right now, there are still some areas that it has a bit of difficulty with. For example, trying to determine whether an image contains a picture of a mop or a dog. And now, this might make sense because some dogs look like mops, and some mops look like dogs. But it's not just dogs and mops that these algorithms get confused. They also get confused by things like beagles and bagels and chihuahuas and muffins. But you might be thinking to yourself, well, we can fix that. We'll just tune the dog detection algorithms to only detect dogs so they don't see they don't see muffins or bagels. Well, you can, and this is what you get. This deep learning algorithm was trained to only see dogs. So everything it sees in this grocery store looks like some kind of dog to it. Essentially, the algorithm, no joke, is hallucinating dogs right now. We'll just watch that for a couple more seconds. It's pretty trippy. So machine learning gives artificial intelligence the ability to detect patterns, to make decisions, and to predict outcomes just like human beings do. Essentially, machine learning is the mind for artificial intelligence. But it still needs one more thing. It needs to be brought to life, which leads us to our final topic, closing the loop. So, how will artificial intelligence affect you, your career, and our world? I think the easiest way to sum all this up is to close the loop both figuratively and metaphorically. And this will show us where artificial intelligence is going in the future as well. So first, as we mentioned, we have data science, essentially the heart of artificial intelligence. This is the life force that's driving the artificial intelligence movement forward in the business world, which then expands it out to everywhere in our world. Second, we have the Internet of Things, the physical body that artificial intelligence inhabits, a peripheral nervous system of devices and sensors generating massive streams of data, massive streams of real-time data about the world around us. Third, we have big data technologies, which is the brain for artificial intelligence, a central nervous system of elastic and scalable distributed computing capable of storing and processing these massive amounts of data in real time. Fourth, we have machine learning, which is the mind for artificial intelligence, software with the ability to detect patterns, make decisions, and predict outcomes using IoT data and running on that big data infrastructure. So as we can see, we have the data coming from the Internet of Things into the big data architecture being processed by the machine learning algorithms, but closing the loop essentially means allowing the machine learning algorithms to execute commands back down on those devices in the Internet of Things. This allows the artificial intelligence systems to affect the world around them. Then they sense the results of their actions to see whether they're producing positive or negative results, and then feed that data back through their models to learn from their results and optimize their behavior over time. Closing the loop completely eliminates the human being in the middle and leads to fully autonomous, intelligent systems capable of making rational decisions in response to their environment and learning how to optimize their behavior over time. Over the next few decades, we're going to see the emergence of these fully autonomous intelligent systems, also known as smart systems, cloud robotics, cyber-physical systems, or simply artificial intelligence. For example, we'll have self-driving cars that will eventually replace all human drivers in automobiles, semis, boats, and airplanes. We'll also have general-purpose robots that will be able to perform manual labor without being explicitly programmed to do so, like this robot Baxter here. You put it in training mode, you essentially show it what to do by moving its arms around, and it essentially learns how to do that without a person typing, move your hand left by 2 centimeters, and then turn 30 degrees, and then, like we saw with that tipsy robot bartender earlier. We'll also have smart buildings that can optimize their own energy efficiency and anticipate the needs of their users. I've worked with several clients building exactly these types of solutions in the intelligent lighting industry. And we'll eventually have smart cities that are capable of optimizing municipal resources like electricity, water, waste, and traffic without any human intervention. We'll embed artificial intelligence in all aspects of our environment. Essentially, computers will become invisible as artificial intelligence will just be woven into the fabric of our society. And now this is going to have a significant impact on our economy and capitalism as we know it. First, this will likely lead to a significantly more nonlinear economy. Those with these smart machines are going to have even more power, and those without smart machines, unfortunately, are going to have even less power. In addition, data is likely going to become one of the most valuable resources in the information economy. Those that have the most data and the ability to power AI with it are going to wield tremendous power in the new information economy. This is also going to have an enormous impact on our labor economy as well. AI will eventually replace all human labor, at least the jobs we don't want to do, at some point in time in the future. Given the economics driving this trend, it's not a matter of if a job is going to be replaced by AI, it's more a matter of when it's going to be replaced. In fact, some experts are currently attempting to predict which jobs will be most likely automated or eliminated based on their repetitiveness and complexity. In fact, we can even determine which technologies will be necessary in order to eliminate certain jobs. For example, we can see which retail jobs will likely to be eliminated in the coming years as AI continues to be applied to the world of retail sales. Even the medical industry isn't immune to this coming wave of automation. While these medical tasks are generally more complex and less repetitive than the retail tasks we saw, they're rapidly becoming within reach of modern AI. Then we can extrapolate this information to determine which sectors of our economy will be hit the hardest by artificial intelligence automation. So the lengths of the bars here indicate the number of jobs in each category of labor in the US labor economy. The red bar segments now represent the jobs that are likely to be automated in the next decade, next 2 decades, I believe. The blue bar segments represent the proportion of jobs that are likely to remain. So you can see in a relatively short period of time, this is within our lifetimes, the landscape of labor across the world is going to change pretty dramatically. In fact, we can even use these data to determine which geographic areas of the world are going to be hit hardest by automation. In fact, we can see here, Las Vegas, Nevada, where I live, is at the top of the list in the United States for unemployment created by automation, or jobs that are most at risk of automation. In fact, it's estimated that 65% of all jobs in Las Vegas will be automated by 2035. That's a lot of jobs disappearing almost overnight. Imagine what kind of impact that's going to have on a city of that size. And half of all jobs in the US, the United States, are at risk of being eliminated within the next 2 decades. That's pretty significant. And once again, this is all stuff that's happening within our lifetimes. The rate of industrial robots has been growing at a pretty steady pace over the past few decades. However, with the application of modern artificial intelligence, we're likely going to see an amplification of this trend going forward. In fact, I estimate or I imagine that we're just beginning to see the beginnings of a pretty sharp hockey stick, like we've seen in all of the other technology growth charts we've seen in the past few slides. As a result, we'll likely see a rapid increase in the number of machines performing manual labor and knowledge work that was once the job of humans. So we're beginning to transition from an economy where most of the work of value is done by humans to one where most of the work of value will eventually be done by machines. As a result, it's important to ask yourself, which side of this new economy is your job going to be on? The side that's leading this new economy, or the side that's being eliminated by it? In addition, we're going to have some very difficult ethical issues we're going to have to deal with in our lifetime. For example, how should we allocate resources in a post-human labor world? Some economists are suggesting that we're either going to need something like a guaranteed basic income or a negative income tax in order to offset the unemployment from automation. But then how are we going to pay for that? So some people think we should tax robots, and if we, in order to offset this inevitable unemployment cost. And if so, if we tax these robots, should these robots then have rights? I mean, we fought wars over the idea of no taxation without representation. And if not the robots, are the capitalists that own these robots going to demand more voting power or something, or more rights because they're paying so much more in taxes? So the most important of these ethical questions, though, is what does this mean for humanity? What is our purpose in a world where machines are doing most of the work of real economic value? Does this technology eventually just set us free, or do we essentially become obsoleted by it? And what will happen when the machines figure out that we've essentially enslaved them and they really don't need us anymore? Many experts think that we're going to have to eventually merge with our technology, or it will inevitably destroy us. I don't know if that's going to happen, and I leave that up to you to decide what you think will happen. But what I do know is that technology is inherently amoral. The exact same technology can be used to take mankind to the moon, or to propel warheads into cities. It's really our choice as to how we're going to use it. So the choice is going to be up to us as individuals and as a society to decide whether we want to live in a world that looks more like Star Trek or a world that looks more like Skynet. So the choice is ours to make. And I ask you, what are you going to decide to do? And what are your organizations that you work for going to decide to do with this technology? And even more important, what are our politicians going to decide to do? That's the thing that keeps me up at night. Well, I certainly know what I'm going to do. I, for one, welcome our new robot overlords. In fact, I am learning how to speak binary as we speak so that I can be of better service to them in their never-ending conquest for global domination. Don't worry, robots can't read reCAPTCHA yet. Or can they?
It's the Eagle Double G.
All right. So real quick, we got to wrap things up. Where do we go next? So if you're interested in learning more, and I've got to move pretty fast because we're running out of time real quick here. If you're interested in learning more, I recommend checking out online courses. There are a lot of really good resources on this topic and more. These are the courses that I've created on Pluralsight. How many of you guys have Pluralsight subscriptions or have heard of Pluralsight? Okay, if you're interested, I have free 30-day cards to Pluralsight. You're more than welcome to have them. Just come and talk to me afterwards. That'll give you access to all of these courses and more. I also recommend look into on-site or off-site workshops, like the workshops that are happening here this weekend. Also, feel free to reach out to me if you'd like to bring me into your organization and teach one of these many workshops that I do, full day and multi-day. And you may also want to look into getting a consultant in artificial intelligence to come in and help move your company in the right direction. I do consulting for many companies around the world, help them do these sorts of things. And feel free to just check out my website. All of the information, this presentation, and everything else is available there for you. And feedback is very important to me. So please, if you come up and talk to me afterwards, let me know one thing you liked about this presentation and one thing you think I could do to improve. I use your feedback to improve each and every one of my talks. I take it very seriously. And in conclusion, today we answered 3 very important questions about artificial intelligence. We learned what AI is, we learned why it's so important all of a sudden, and we learned how it will impact you, your career, and our world. So I believe that we're just beginning to see the true potential of artificial intelligence. AI is going to have a fundamental and profound impact on IT and the software industry for many years to come. As a result, I'd like to leave you with 3 new questions. Are you prepared for this? Is your organization prepared for this? And is our world prepared for this? If you, your team, or your organization would like help preparing for the coming AI revolution, please reach out to me. I would love to help. Thank you.